In this video, we're going to be looking at classifying quadrilaterals. The first thing we need to do is identify what a quadrilateral is. The word quadrilateral I have highlighted in yellow. Quad means four. Lateral means side. So a quadrilateral is a four-sided shape. Each of those sides are a straight line. There are some special types of quadrilaterals, and we classify them by a number of properties. These properties could be their sides being parallel, they could be the sides being the same length, and other similar properties. These shapes are parallelograms, rhombuses, rectangles, squares, kites, and trapeziums. We will look at these shortly. When a quadrilateral does not have any of these special properties, then we call the quadrilateral irregular. With irregular quadrilaterals, all of the sides are of a different length. All of the angles formed by two sides will be different as well. There is a common feature for quadrilaterals. This common feature is that all the angles in a quadrilateral add up to 360 degrees. To the right, there is an irregular quadrilateral that is drawn. This rule is true whether a quadrilateral is irregular or not. One angle, A, plus another angle, B, plus another angle, C, plus another angle, D, all add together to equal 360. That is true for any quadrilateral. What does this mean? It means if we know one of the angles, for instance, D, and we know another angle, for instance, A, and another angle, for instance, B, we know three of the four angles. Because we know the four angles, A, B, C, D, must add up to equal 360. If we add A, B, and D together, and take that away from 360, that will give us C. Now we're going to consider some special quadrilaterals. Here are 6 quadrilaterals. The first one we have is a square. On our square, all sides are equal in length. This is often represented by using a little line, like that, like that, like that, and like that. That one line indicates each of those sides are the same length. Also, each of the angles formed by two sides are 90 degrees. They are right angles. So on my square, there are 4 angles of 90 degrees. Next, we're going to consider the rectangle. The rectangle has opposite sides being equal. So the two red sides I've marked with a single line through them. That indicates they are the same length. Those two sides are opposite each other. The two blue sides are also opposite each other, but I wouldn't represent those two sides with a little line through them because I've already used one line, so I would use 2 lines. So putting 2 lines through each close together indicates those two blue sides are the same length. The other feature we have is that all angles are 90 degrees. So there are 4 corners of 90 degrees. Now we're going to consider the parallelogram. The parallelogram has the word parallel at the start. That is because there are 2 pairs of parallel sides. So if I looked at the red sides, they are the same length and they are parallel to each other. So I've put a little line through both so you can see what I mean. On the blue sides, those 2 blue sides are also parallel and the same length. That is similar to the rectangle. The difference is the rectangle has 4 angles of 90 degrees. The angles are not 90 degrees in parallelograms. So if you look on our parallelogram, I'll use the green highlighter, there is an angle I've marked in green and an angle I've marked in green. Those 2 angles are opposite each other. They're not 90 degrees and they are equal to each other. There are 2 other angles opposite each other marked with a red line, and I'll mark them in blue. Those 2 angles are opposite each other and are equal. The next shape is the trapezium. In America, they're called trapezoids. Be careful with the words there and do not be confused. Trapezium is singular, meaning 1. Sometimes you'll see trapeziums with an S on the end written. Sometimes you'll see trapezia, I-A on the end. Both are plural. Now with a trapezium, there are 2 parallel sides. How am I going to mark the parallel sides? I'm going to mark them with a little arrow pointing in one direction. So the 2 sides that are parallel with a little arrow pointing in one direction. The other 2 sides are not parallel. There are numbers of ways we can draw trapeziums. For instance, we might have a shape like this, where we've got a flat bottom, 2 parallel sides going up, one longer than the other, and a slanting side joining them. Or we could have something like this, or something like that. There are lots of ways we can draw our trapeziums, so you may have to think in your head to rotate the shape. The next shape we have is a rhombus. A rhombus is a type of parallelogram. It has 2 pairs of parallel sides. The thing is, each side is equal in length. So I'm going to use one little dash line through each of those sides. Those sides are equal in length. It does, though, still have 2 parallel sides. Now we can indicate parallel sides with our little arrow. So those 2 sides are parallel. The other pair of parallel sides, I've already used one arrow to show 2 sides are parallel. So we can do 2 little arrowheads to indicate those 2 sides are parallel. Now we need to look at the angles. The opposite angles will be the same length. So the blue angles at the ends, they are the same size, not the same length as I just said, and the other two opposite angles are the same size. The last shape is the kite. The kite has adjacent pairs, so we've got the word adjacent. Adjacent next to. Adjacent pairs of sides are equal. So there are two pairs of adjacent sides in this diagram. One pair is marked in blue. The other pair is marked in red. In this example, we're asked to classify a quadrilateral. So we have to look at the shape and work out what type of quadrilateral it is. It has one pair of parallel sides. How do we know they're parallel? Because they have the little arrowheads indicating that. One pair of parallel sides, it is a trapezium. In this example, it says find the size of angle X. So what you have to remember is the four angles in a quadrilateral add up to equal 360 degrees. So that is our thinking. So what do we know? We have X plus 115 degrees plus 95 degrees plus 115 degrees equals 360 degrees. So what we're going to do is we're going to add up the three numbers that we know. So we've got X plus 115 plus 95 plus 115. 115 plus 115 plus 95 equals 325. So we have X plus 325 degrees equals 360 degrees. So we have added up the three numbers, and that gave us 325. Now what we want to do is get the X by itself. So I'm going to subtract 325 from both sides. X plus 325 degrees minus 325 degrees equals 360 degrees minus 325 degrees. The 325s have cancelled on the left-hand side, leaving me just with X. 360 minus 325 is 35 degrees. So the size of angle X is 35 degrees.